So what I'd like you to do is we're going to graph these lines. And you should know how to do this. We have been doing this for weeks and weeks and weeks on end, right? Feels like years. So we have two equations. I'll help you with the first, these ones, and then you can do the rest. So the first equation, in order to graph 2x plus y equals 3, what do we have to do to this equation? Make it y equals. I feel like we sound like broken records. So first step when we want to make something y equals in this specific case is we're going to do what? Move the x. So how do we move the x? Subtract 2x. Very good. The x's cancel out. And we're left with y equals negative 2x plus 3. Very good. So in order to plot this, what's the first thing we're going to plot? Y-intercept is 3. So let's plot that. And our slope is down to right 1 because it's negative 2. And to make it a fraction, we put it over 1. So that's rise over run. If we're doing rising negative 2, we're actually going down 2. And then right 1. Down 2, right 1. Make a few points. Alrighty. So if you have a ruler or use your calculator or whatever you have, or just do a rough sketch, let's draw a line through these points. And there you go. So that's the first equation. Second one, same idea. We have y minus 8 equals negative 2x. In order to graph it, isolate the y. So who's hanging out with y right now? No, the negative 8. Minus 8. And so to move the minus 8, plus 8. Yes, I did. Buy new rulers. Y equals negative 2x plus 8. Negative 2x plus 8. Okay, so again, the first thing we're going to plot. Y-intercept is positive 8. That's our constant. And our slope here is down to right 1. We got this in the bag, right? Alrighty, beautiful. What do we have here? Parallel lines. So today's lesson is on the number of solutions we can possibly have when we have intersecting lines. So when we have parallel lines, how many times will it intersect? 0. And so there is no solution. Remember, solution with a system is when it intersects. And so if it never intersects, we have no solution. So all parallel lines have no solution. There is no intersection point. No solution. So how do we spot when we have parallel lines? What's the easiest way to spot if we have parallel lines? You graph them. Same slope, but different y-intercept. But different y-intercept. So we didn't actually have to graph them. If we just look at their slope, they both had a slope of negative 2 and different y-intercepts. And so just looking at the slope, because they have the same slope but different y-intercept, we know they're going to be parallel lines. We're going to do that next. So the question was, what if they're the same line? So we're going to do that next. Just to finish off parallel lines, if you're algebraically solving, and say you had algebraically, and so you're using, let's say we're using elimination. So you had 2x plus 3y equals 10, and 2x plus 3y equals 2. And those are your two equations. Now, because our coefficients are the same sign, will we add or subtract? Say for x's, same sign. We're subtracting. So 2 minus 2x, what's going to happen? cancel. 3 minus 3 is going to cancel. So on this side of the equation, we get 0 equals, what's 10 minus 2? 8. And so whenever you're left with 0 equals a number, that's parallel lines. Like, that's not possible. It's an inconsistent system. And so if that ever happens when you're solving algebraically, and now all the x's and all the y's cancel out, the reason why the x's and y's cancel out is because they had the same slope, because they were multiplied by the same factor. So the slopes were going to be the same, the y-intercepts are different, the constants are different. And so if you ever get to a situation where you have 0 equals like 2 or 0 equals 10, that's parallel lines, no solution. All right. Yep. Or which part? This part here? 0 equals a number? No, you could just figure out by changing them to y equals to figure out if there's no solution. I'm just saying if you were working through it algebraically and you get to that, then that's how you tell. Okay? All right, so can you please graph both these lines? Okay, the first equation, you should have had negative x plus 3. And so your y-intercept is 3, slope is negative 1. To make it a fraction, we put it over 1. So we would have been at 3, and then down 1, right 1, down 1, right 1. So that's your first line. Now something crazy should happen in this situation. It's the same line you should have had. Okay, so how do we know that? Well, in the next one, if we solve for y equals, subtract the 2x. We have 2y equals negative 2x plus 6, and then divide everyone by 2. Y equals negative x plus 3. So if you have a highlighter or another colored pen, just to show that it's two lines, but the same line, let's draw the line over top. Oh, I'll fix that. Right, it's the same line. So if you have a highlighter, maybe draw just to kind of show. These are the same line. And if you really look, you can also spot that they're same line because one is just double the other equation. Everything's doubled. The x, the y, and the constant. For your second equation, your slope obviously was also negative 1. And your y-intercept was 3. So how many solutions do they're called coincident lines have? Infinite. Why? Because remember, it's how many times do they cross each other. A solution is the intersection points. How many times do they intersect? Forever, everywhere, right? At all the points they're intersecting. So they have infinite solutions. Infinite solutions. Now, how do we spot infinite solutions or coincident lines or same lines? Slope and y-intercept are the same. Algebraically, because they're completely identical, if you use either substitution or elimination, you'll get down to 0 equals 0 because everything's going to cancel out because they're identical lines. So if I subtracted two identical lines from each other, they'll just get 0 equals 0. And so if that ever happens algebraically, where you get 0 equals 0, that's because it's the same line, same equation. Okay? So there's three different ways, right? If we have two lines, they either can be parallel, they can be the same line, or they can have one solution, one intersection point. So notice the pattern. If it's parallel, they have the same slope, different y-intercept. If it was coincident, same slope and same y-intercept. So how do you think we spot intersecting lines when there's one solution? Different what? Does the y-intercept have to be different or just the slope? You can have the same y-intercept, but different slope, because if you have the same y-intercept, that just happens to be your intersection point. So the only thing that makes something intersecting lines, as long as the slopes are different we have intersecting lines. So there's one solution, and the easiest way to spot that is they're just going to have different slopes. Different slopes. The y-intercept can be the same or it can be different. So all we're always looking at is the slope. And only if the slopes are the same do you have to look at the y-intercept. So different slopes, y-intercept can be the same or different. Doesn't matter. If it's the same, that just happens to be your intersection point. For algebraically, when you actually solve, you'll get a variable equals a number. It's what we've been doing all along. So can you go ahead and graph these two lines? They should have different slopes. So solve both of them for y equals and plot them. So your first graph, you should have had a y-intercept of 4 and a slope of negative 2 over 1. So down 2, right 1. Just fix that. Okay, your second equation, you should have had a y-intercept of 3 and a slope of negative 1/2. So as long as your slopes are different, so down 1, right 2, down 1, right 2, then we have intersecting lines. Their rate of change is different. They're going to cross at some point. So we'll have one solution. So those are the 3 different situations. Okay, so you can finish drawing that. So just a little side note, maybe you can write at the bottom of your page or the top of your page. The easiest way to tell if there's one solution, no solution, or infinite solutions is to do what? What did we do in all 3 of these situations? Put it into y equals, put into y equals mx plus b, and look at the slope. If the slopes are the same, then we have to look at the y-intercept. That's the easiest way. Put into y equals mx plus b and look at the slope. If the slopes are the same, then we have to look at the y-intercepts to see if they're going to be parallel or the same line. So on the next page, there's 4 questions. All I need you to do is tell me if there's one solution, no solution, or infinite solutions, and explain your reasoning. So explaining your reasoning would be saying, like, they have the same slope, or they have different slopes. Okay? So can you work through those 4 questions here? So yeah, put it in y equals mx plus b, look at the slopes. So give this a shot. The first equation was already in y equals mx plus b, so all we had to look at their slopes. So slopes are different, so you should have said one solution, and the reason why is they have different slopes. Don't even have to look at the y-intercept unless the slopes are the same. So different different slopes. Okay, the next one, rearranging these bows for y equals. So the first equation, subtracting 4x over, we have 10y equals negative 4x plus 30, then divide by 10. We have y equals negative 2 over 5x plus 3. The second one, I subtract 2x over, I have 5y equals negative 2x plus 35, and divide by 5. You should have had y equals negative 2 over 5x plus 7. So their slopes are the same. So then we look at the y-intercepts, and the y-intercepts are different. So if we have same slope, different y-intercept, parallel lines, therefore how many solutions? None. So no solution, and your reasoning would be same slope, different y-intercept. All right, so next equation, solving again for y equals. Okay, so the next guy getting y by itself, subtract the 10x, and we have negative 6y equals negative 10x minus 12. Divide everyone by negative 6. When you reduce, you should have had 5 over 3 positive 5 over 3x plus 2. The second equation, we just had to divide everyone by 21. And I'm going to rearrange this and put the x first. So when we divide everyone by 21, you should again have positive 5 over 3x plus 2. So what do we have here? Coincident lines, therefore how many solutions? Infinite. They're the same line. Infinite solutions because your reason could be the same line or same slope, same y-intercept. And the last one, we just had to rearrange the first one. The second was already done for you. So add the 4x to the other side. Divide by 6. And again, y equals 2/3 x plus 1. Slopes are the same. Y-intercepts are the same. Therefore, we have infinite solutions. And reason would be same slope, same y-intercept. Okay? So that's today's lesson. The homework, the bottom of the page, 448. So it should be a pretty easy homework assignment. If you finish early and you're all caught up with homework, I'll get you started on tomorrow's lesson. And so tomorrow's lesson is just mixing it all together, so either solving by substitution, elimination, or graphing, and it's with word problems. All right, and then that's it. All right, thanks guys for listening.